Okay, this is a little video to show you how to use MR-QAP. What we're going to do is use that AVG network that we had created, which was the average of all of the other networks. And I don't know what I've done with it here, so I'll just type in AVG and move that up here. Okay, so that's the strength of ties that we're going to try to predict. Of course, we need something to predict with, and we've got a series of attributes of the organizations. So let me display those. Those are DAR attributes. And we have several to work with, including partner type, primary goal, advocacy, time, and so on. So let's close this window and let's convert some of these attributes to matrices so that we can then use the MR-QAP procedure. So I go to data, I choose attribute to matrix. The input attribute data set in this case is DAR attributes. And we need to pick an attribute. I'm going to choose partner type, which is a categorical attribute, and in the case of categorical attributes, we almost always want to use exact matches. It's would be very surprising if we didn't. So I'm going to make a short name, which is going to be the same partner type. Run it. Now I've got it created, and I can now do the regression. I'm going to press Control R to get there, but of course one can also go to Tools, Testing Hypotheses, and run through the whole set of menus, but it's just so much easier to press Control R. So here's the dependent variable. That's going to be AVG, that's our network. Our independent variables, well, we've only got one to choose from at the moment, the one that we just created, which is same partner type. Number of random permutations, probably 5,000 would be a bit better. Really, we should be bumping it up quite a bit more. But for the purposes of demonstration, this is good enough. We get our R square, which is not significant. And that's essentially the same thing here. And so same partner type is negatively related. So partner type, as I remember, was whether you're like a lead or a follower, and so obviously the leads are going to be partnered with followers and vice versa, so it should be negative. So that's good. Let's create another similarity matrix, going attribute to matrix, choosing primary goal, another categorical, and we're going to call it the same primary goal. Exact matches. We run it. There's our matrix. Close that. I press Control R, and I now add in same primary goal and run it. And it's significant in a positive direction. So in other words, organizations that have the same primary goal tend to have stronger ties with each other. Now we go to data again, attribute to matrix. We choose something else. This time we're going to choose advocacy. And this is an ordinal attribute. So here we want to do something like difference. And so we'll choose difference, and we'll call this difference in advocacy, diff advocacy. It's been created. Control R. Diff advocacy. Run it. And it's significant in the positive direction, so that means that the organizations that tend to have stronger ties with each other tend to have different levels of advocacy. So maybe they're somehow complementary or something. Now, we'll do one more attribute to matrix, and let's choose time. And the idea here is to see whether organizations that have been in the business longer are more likely to be tied to each other. So we'll use the product. So the only way to get a big number between two organizations is if they've both been around for a long time. We'll call that prod time. Choose OK. Take a quick look at it. Close it. Do Control R. Prod time. Run it. Interestingly, now that we're controlling for lots of different things, same partner type is significant. And the product of time in the business is also significant in the positive direction, as we expected.